Hello students, welcome to the next lecture on the multivariate normal distribution. Today we will describe what are the various properties of the moment generating function. Myself Dr. Harishkar. You can follow my YouTube channel where you can find the playlist of applied mathematical analysis and you can see the various lectures related to the bivariate, multivariate, transformation of the multivariate, independent, marginal, conditional, example of the conditional and many more lectures in this playlist. You can simply subscribe my YouTube channel so that you can get your notification when I upload the new video on this topic. So what we have discussed last lecture related to the moment generating function. Moment generating function of a random variable x. What is the meaning of the x belongs to this? That means x is consist of a vector with p elements and it having the mean mu and variance sigma. Fine, that is a positive covariance matrix. Then you can define the moment generating functions of x, which is denoted by m of x, and t is defined as expected value of this. Clearly say what is the meaning of this t. Again this meaning t1, t2, and what is the dimension is p. So it is of the p dimension and each of the ti's are my real number. So this is the definition of the moment generating function. And when you have the multivariate normal distribution x, then in the last lecture we have defined the moment generating functions which is available in this lecture. You can subscribe and follow my YouTube channel for these lectures. Now in this lecture we will see what are the various properties of the moment generating function that this satisfy. The first property is if x follows the normal distribution, multivariate normal distribution with mean vector mu, and this is sigma is called as positive covariance matrix, then mx of 0, that means whenever t is 0 the moment generating function is 1 always. The proof is very simple. We can start from the definition. So now clearly say at t is equal to 0. So if I substitute t is equal to 0, what is my left hand side? Mx 0. What is the right hand side is this, t is 0. So 0 multiplied something is my 0. Fine. What is the e raised to power 0? Is 1 and expected value of the constant quantity is constant quantity. And that's the proof of this property number 1. Second property is if x follows the multivariate normal distribution and y is my some translation, that's the shifting the origin, then you can find the moment generating function with respect to the moment generating function of x. Very simple. I can start with the definition of moment generating function. What is the definition of the moment generating function for y? It is expected value of e t transpose of y for every t which belongs to the R of p. Fine. Now I can substitute the value of the y. Y is given as x minus y. So it comes to be expected value t dash of x plus t dash of a. T dash means that's a transpose of this one. Now I can open this bracket. It is t transpose of x into t transpose of a. Now since this number is my constant and we all know expected value of ax is a times expected value of x. So I can written this quantity as t transpose a expected value of this number. Fine. Now it is clearly say what is the definition of this. It is the definition of the moment generating function of x. So it is a t transpose moment generating function of x, and that's the required proof of this property number 2. Property number 3 is if x follows the multivariate normal distribution, then moment generating function of x minus mu. That is a similar, this is an example of this. That means if I simply take a is my minus of mu, fine, then we have to find this moment generating function. So that's why it is an example. So by the definition of the moment generating function of the x, we have this property. Now since x follows my multivariate normal distribution with the mean mu and covariance matrix sigma, so what does it implies? What does x minus mu? It follows again a multivariate normal distribution, mean is 0, positive covariance matrix sigma. Now it is a multivariate normal distribution, so clearly say I can use this. What is the mu? What is the mu for this case? It is my 0 and sigma will be my sigma. So I can substitute these two values in this expression. Mu is my 0, so you can see this value will be 0 and the right answer is my same expression of this case. Look at the another property. Now you can see the last property was how you can find the moment generating function of shifting the origin. Now in this case, how you can find the moment generating function? Instead of the shifting origin, you can scale the random variable x. Then the moment generating function is defined like this way, where a is any scalar vector. That means in this case a may be 4 or a may be any of the vector 1, 1, 2 or any of the things. So again a very simple, I can start from the moment generating functions of the y. I can substitute the value of the y is my ax. Now we all know what is the property of the AB transpose. This is B transpose into A transpose. So can I write this? How I can write this property of this? How I can correlate them? T transpose of A. Can I write this number as A transpose of T? Because if you open by using this property, it is the same. So I can say this is A transpose of T. Fine. Now if you think about A transpose of T is say my B. So this expression will be expected value B transpose of X, and B is my real number. Fine. So what is the given to you? This is the definition of the moment generating function of B. Fine. So what is the meaning of that? This is moment generating function of X with the parameter A transpose T. So that's the required proof of this property. So let's say one example corresponding to this also. If X, what is the meaning of the N3? That means X will be my X1, X2 and X3, such that the mean is given to be 2, -3, 1 and sigma, that is a positive covariance matrix, is given to be this number. Then you have to find the moment generating function of 3x. That means A is my 3. Fine. So that's very simple. I can start from the moment, because it's a multivariate normal distribution. So the MGF is given by this. So now can you take the T? What is the dimension is 3. So I can take T is my T1, T2, T3. Fine. So which belongs to my R of 3, because N is my 3. Now I have to find the moment generating function of the 3x. By this property, it is my A transpose. A is my 3. What is the transpose of the 3? Is again 3. So I can substitute this number here. What is that? It will be e raised to power transpose. What is the transpose of this? Again it is the same quantity, this, plus what is that? T transpose sigma of T. This will be 3T transpose sigma will be sigma of this quantity. So what is the expression of this? 3 transpose is 3, 3 into 3 is 9, T transpose sigma of T. So I can substitute this number as 9 T transpose of this. Now your target is to find this number. What is that? T transpose will be T1, T2, T3. What is the mu? Mu is my 2 minus 3, 1. So can you calculate that? It will be 2T1 minus 3T2 plus T3. So that's the value of this number. Now second part, we need to calculate T transpose sigma into T. Fine. So that you can see it's a, I can multiply this by 6. It's a minus. This number is my minus. How you can find this number? So T transpose, let me write here, T transpose sigma of T. It will be T1, T2, T3, and what is the sigma? Sigma is my 1, 2, 1, 2, 3, 1, 1, 1, 2, and it is my T1, T2, T3. Fine. One way is that you can multiply this matrix and get the result. Otherwise, because this matrix is my symmetric, fine, and positive definite, because sigma is my symmetric and positive definite. So you can write it directly. This is my T1 square, this is my T2 square, this is my T3 square. Fine. Plus add these pairs, 2 plus 2 4, this is my 1 and 2, T1 T2. Add these pairs, this is a 1 and 3, so 1 plus 1 is 2, T1 T3. Add these pairs, this is my twice T2 T3, and you can see I have written in this manner, and that's the right answer of this problem. If I look at one more example, in this case you can see, firstly again the same example I have taken. So the moment generating function is defined like this manner. So what I can do is I can take y is my x1 minus x2 plus x3. Fine. So what is your target? Your target is to find the moment generating function of y. Fine. How you can find the moment generating function of y? For this you need to find the mean of the y, and you need to find the covariance matrix of this y. Once you can find the mean and the covariance, I can replace the value at this point. Now how you can find the mean and the variance? That's by using the transformation method. Fine. How you can find that transformation? You can see this lecture, how you can find the transformation of the multivariate normal distribution. Otherwise you can correlate them. I can say this is my AX. What is the A? A is my coefficient of x1, coefficient of x2, coefficient of x3. Fine. So this is my A. Now what is the rank of this matrix A? So since it is my 1 cross 3, rank is my 1, which is less than of 3. That is my this dimension. So what is the meaning of that? Y will follows the multivariate normal distribution with dimension 1, and the mean is A mu and variance is A sigma A transpose. Now your target is to find this value A into mu. Your target is to find this number. So what is the A? A is my 1 minus 1 into 1. What is my mu? Mu is my 2 minus 3 into 1. So can you multiply them? 2 plus 3 plus 1. So it will be my 6. Fine. So basically this is my mean of the y. This is covariance of the y. Again you can substitute the value of A, sigma, and this number. So what will it happen if you multiply this matrix? So it will be 2 minus 6 plus 1. So it is minus 3. Then 4 minus 9 plus 1. It is minus 4. And the last value will be 2 minus 3 plus 2. It will be 1. So if you multiply them, it is a minus 6 plus 12 plus 1. So it is 6 plus 1 is 7 is my covariance matrix of this. So therefore y will follows the normal distribution with the mean 6 and variance 7. Fine. Now once you know it's a univariate because it's a dimension 1, so you can find the moment generating function. We all know the moment generating function for the univariate is sigma square t square. So that means 6 into t plus sigma square, that's a variance, 7 t square by 2. This is the first method. Fine. Otherwise second method is, because it's again a multivariate normal distribution, so I can replace this value. This is a mean. What is the mean of the y? This number. Again same expression, I have to replace the mean of the y. This is the positive covariance matrix of this positive covariance. Now I can substitute this value A mu 6 into t dash, and here because it's a single, what is the value of that t? It's a r p. P is my 1, so it's a single number, so it's a 7. 7 t into t is my t scale. Look at this another property. If xi's are my independent and follows the multivariate normal distribution, and capital X is the sum of them, then you can find the moment generating function of the x. What is given to you? Xi's are my multivariate normal distribution. So what does it mean? by the definition of the moment generating function, you can define its, this is t dash of mu plus this number. Now let's start with the left hand side. I can substitute the value of the x, this one, because again I can return this number is t1 x1, because in this case what is my t? T is from the r of xm, so it is m, that is t1 t2 up to t of m. This is the value of small t. So now because it's a product, so I can return this is my t2 x2 into e raised to power tm xm. Now it is given that they are independent, so by using the property of if x and y are independent, then this quantity will be ex into ey. So I can return this number as e raised to power t1 x1 e of t2 x2 and so on, that is e of tm xm. Now by using the definition of the moment generating function, this is my moment generating function of x1 over the parameter t1. This is the moment generating function of the x2 over the parameter t2 and so on. Because x1 is a single variable, so either you can write as a t transpose or the t, that's the same meaning of it. Now I can write this number as product I varies from 1 to m, mxi of t is the required proof of this property. Look at one more property. Now that's a combination of the previous two. Earlier we have defined the moment generating function of this. We have defined the moment generating function of this. Now I can combine this property and we can find the moment generating functions by this method. Again a very simple. Let's start from the left hand side. Substitute the value of the y. Y is ax plus b. Fine. I can open this bracket. It is t transpose ax into t transpose of b. Because t is my real number, b is my real number, so this number is my constant. I can take on this part is outside. So that part I can return like e raised to power of x. So how you can define this number? As we have defined previously, by using the same property, AB transpose is B transpose A transpose. Fine. Now you can see this property. What is that? This portion is my moment generating function of, this is the moment generating function of x, but the parameter is A transpose into T, and that's the required proof of this property. So let me explain this question with the help of the example. I hope you can like my video. I feel it's very useful for you to understand in an easier manner. Now what is given to you? X is my n3, that is x1, x2 and x3. Which follows there? The mean is given to be 1, minus 1, 0 and the positive covariance matrix this. Find the MGF of y1, y2. That means your target is to find the moment generating function of y, which is my y1, y2. That means it follows n2 because it's a two variable, mean of the y and sigma of the y. So definitely your target is to find mu y, your target is to find covariance matrix of this. How you can find that? Again by using the transformation method. Fine. So let me explain you. I can write this y is a pair of x. What is the coefficient of x1 in this line? 1. Coefficient of x2 minus 1 because it's a x3 also. Coefficient of x3 in this case 0. Coefficient of x1 in the y2, x2 and x3, that's the first component. Plus this is the constant, plus 2 and minus 1 I can return here. So if you compare this equation by ax plus b, so your a will be my this number and b is my. Now your target is to find the moment generating function of this. So what is the rank of this matrix? It's a 2 cross 2, so 2 cross 3, so rank will be my 2, hence y is my this number. So again your target is to find the mean of y and positive variance of y. So this number is my mean of the y, this number is covariance matrix of the y. So how you can find that MGF of y? There are the two methods. First method is by using the transformation. What is the meaning of that transformation? If you use the y, it is a mu y and sigma y. What is the mu of y and sigma of y? So mu of y, that's a mean, a mu plus b, and this number is a sigma a transpose. So I can substitute this value. What is the a? A is my 1 0 minus 1 1 0 1. What is the mu? 1 minus 1 0. And what is the b? 2 and minus 1. So if you open this bracket, what will happen? You can open this bracket, it will be, if you multiply them, it is 1 plus 1 plus 0, that is 2, and 0 minus 1 0 plus 2 into minus 1, so it will be 4 minus of 2. That is a mean of y. Fine, it's a 4 and minus 2. Now I can substitute this number here, minus 1 1 0 1. What is my sigma? Sigma is given to be 1 1 2 1 3 2 2 2 1, and this is a transpose. So 1 0 minus 1 1 0 into 1. Now can you multiply this matrix? That's easy for you. You can use your calculator or you can multiply by hand. So first row, first column. So 1 minus 1 plus 0 is 0. Second 0 plus 1 plus 2, that is 3. Then second row, first column, 1 minus 3 plus 0, and this one is 3 plus 2 5, 2 minus 2 0, 0 2 plus 1, that's 3. Now once you can get this matrix, you can multiply them again, so you will get 3 5 3. You can see here, once you multiply this number, you will get this matrix. So this number is my covariance matrix, this number is my, now since it is my y2, so what is the value of that t? T is my only t1 t2. So I can substitute this value here, mu y, this number is my mu y, and sigma y is my this number. So once you multiply them, you can see it's a 4 minus 2t2, because it's a positive square, positive symmetric matrix. I can write as a 2t1 square plus 8t2 square minus, what is the sum of this? Minus 4 t1 t2. Now you can take the LCM and you will get this result. Now this is the first method. Second method is I can use by the property. What is the property of the moment generating function y? By here, it means I need to find t dash of b. This is my first target, and my target is to find this number. Fine. Now what is the value of t? Because y, what is the dimension of the y? Y is my n2, so I can take t is my t1 t2. I can substitute this value on this part. Firstly, t dash of b, what is the transpose? What is this number? I can return this number is t1 t2, and this is 2 minus 1. So what is that? It's a 2t1 minus t2. Fine. Now what is the a transpose? A is my this, it's a 1 0 minus 1 1 0 1. What is that t? t1 t2. Now if you multiply them, it will be t1 minus t1 plus t2 and t2. Fine. I can substitute this value here. Now my target is to find the MGF of x. What is the MGF of the x? It is e raised to power t transpose mu plus half t transpose this quantity. Fine. I can substitute this value. What is that? This is a moment generating function of the x. X is my 3 dimension. Fine. What is the mu? Mu is my this value. So for this case, I can take t1, t2, t3. I can substitute this value at these points. You can calculate this number t dash minus mu. So what is that? t1, t2, t3. What is the mu? Is 1 minus 1 0. If you multiply them, you will get t1 minus t2. How you can find that? Again, you can see t1 square plus 3t2 square plus t3 square. What is the diagonal entries? You can see this is a 1, 2. That is a 1 plus 1 twice. This is 2 plus 2, 4. And this number. Now, I can find this value at this point. What is the meaning of this? What is the A transpose X? This number. So that means, what is this number? Mx of this part. Fine. So how you can obtain that? I have to replace, what is that? Wherever the t1 written, I have to return t1. Wherever t2 written, I have to replace by minus t1 plus t2. Wherever t3 is written in this case, I have to replace by t2. So I can substitute all these values in this case. You will get this expression. Now you can take the LCM. It is exponential. I can take the LCM of 2. It is my 4t1 minus 2t2. I can open this square and you will get this expression. Now you can simplify it like this is a t1 square, this is a 4 minus of 2. That will be my 2t1 square. Similarly, you can simplify it and divide it by 2. So if you divide it by 2 and you will get this answer. Now I can substitute this value and this value at this point. So what is the E of, so therefore moment generating function of y will be, what is the, this part is e raised to power 2t1 minus t2 into, what is the answer of this portion? E raised to power this portion. Fine. Now you can add them, you will get this is the same right answer of this problem. So this is the way you can use the properties and their corresponding moment generating function. We will see the next lecture on the characteristics function of the multivariate normal distribution. Till then, you can like, subscribe and comment on my videos. Best of luck, students. Happy learning.